Hi everyone, welcome to Learning Rust with Sean and Kate. Hi Sean,
Hey Kate, how you doing?
doing well. Today we're going to talk about using structs to structure related data, which is chapter 5 of Rust programming language. So
Nice, I'm excited about this.
yeah, it's going to be great.
Do you like my new recording equipment, by the way?
I do. It's very professional.
Yeah, so I have just seen so many streamers over the years, and now I've got the full experience.
Yeah, next time I see you, you're going to be in a full studio.
I've got a joke for you though, because I know today we're going to be covering some Pokemon stuff.
All right, hit
You
me.
ready? You ready for this?
Let me just take a drink.
Okay.
Okay, ready.
So why can't you blindfold a Pokemon?
Why?
Because it's going to Pikachu. Whoa!
All right.
Nice.
So, just to explain why we're talking about Pokemon,
Isn't it self-evident? Strux and Rust and Pokemon.
yeah,
My
obviously,
mind connects those two things immediately.
we were trying to think of an example that we could use to demonstrate some of the new things we've learned in this chapter. So, the idea is that we would create a Pokemon struct that has some properties and then fight them to the death, or
Yeah.
something like that.
No, they don't kill each other. It's violent, but it's not fatal. They just get knocked out.
Okay. Basically, we were thinking about this in two parts. First, we would create that struct, and then second, we would create a function with all of the game logic that would basically match them against each other and return the winner. So, yeah, do you want to talk through this first part, Sean?
Sure, absolutely. So you're going to start by just creating a Pokemon struct, and it's going to have a variety of fields. When I read about how Rust structs work, it felt very familiar to me compared to the C programming language. Pretty much, it works exactly the same, at least at that particular level.
Mm-hmm.
And the advantage of using a struct versus what we learned before, like tuples, is now we've got the ability to not only um, group content together, we have the ability to provide more semantic meaning around it, both at the kind of the overarching object and then also the various fields.
Mm-hmm.
So our Pokemon struct is going to have three different fields: a name, health, and an attack bonus. And we don't have the types here, but I guess we should kind of think about what might be useful there. So I
Sure.
guess a name that would be like a string, right?
Makes sense. Yep.
And then health and attack bonuses, I guess integers.
Mm-hmm.
Yeah, and so then it looks like we're going to add some methods so they
Mm-hmm.
can do stuff, and that's kind of the cool new part where um, Rust has that special IMPL keyword where you can
Mm-hmm.
basically decorate a struct with a series of behaviors and then have a special reference to self, which works really nice ergonomically, I think. Did you like that, Kate?
Yeah, it definitely made me feel at home because it feels very similar to how methods in JavaScript can work with like the this keyword. And yeah, it's nice to be able to group the behavioral logic with the struct to keep everything organized.
Cool.
So here we're going to implement two methods: attack, which will just return the Pokemon's attack bonus plus a constant value attack value of 2, or I guess we could make that whatever we want. And then an is defeated method, which just checks whether their health is greater than 0.
Hmm.
And if it is, then is defeated is false. But if their health value is 0 or negative, then is defeated returns true. That will probably indicate what types we should choose for the health and attack bonus.
Hint, hint, hint.
Yes.
You're
And,
dropping hints, Kate.
and this second part, we're going to create a function that actually simulates the battle. So it's going to take two arguments, which are going to be instances of Pokemon.
Mm-hmm.
And whenever one of these instances health reach 0, then we'll return the other one. So each Pokemon's attack method will indicate how much health to subtract from the other Pokemon.
Uh-huh.
So, yeah, whenever one of them reaches 0 or negative, then we return the winner. And here's kind of an example of what we're thinking. Oh, our JavaScript is showing.
Yeah. Well, it's also highly questionable that Snorlax would win a battle.
Yeah. So we have,
Just doesn't have the energy for it.
yeah, health is 100 and attack bonus 50.
That's unrealistic.
Very unrealistic. So the first step, I think, would probably be creating our Pokemon struct.
Mm-hmm.
So I'm going to go ahead and declare that. And we know that we're going to have a name field, a health field, and an attack bonus field.
Mm-hmm.
All right, so name, pretty straightforward, like you said, string, makes sense. All right, so health and attack bonus. What do you think about that?
I mean, I'm thinking some sort of integer. I'm not totally sure which type. I mean, I guess it doesn't need to be that big. It looked like health was like 100 or something like that. So
Yeah, I guess
maybe
it
like an I8 or something like that.
that makes sense. I guess technically it could be anything, really, but we could maybe set some artificial boundaries for ourselves.
It could be.
Yeah.
It could. Yeah.
So then why don't we go with that? Because we know that health could be 0 or negative. So might as well start there.
Cool. That looks good to me. I'm curious. Does this compile?
Let's try it out. Do we want to print something in our main function?
Yeah, maybe a hello world.
All right. Okay.
Maybe semicolon.
Yes, thank you. I guess maybe this needs a semicolon as well? No, does not.
I'm not even sure.
All right. So our compiler is saying that we do not need a semicolon.
Okay.
Great.
Good to know.
All right. So we've got some dead code. That's fine. We know that.
We expect that.
Yes.
Cool. So should I create the constructor then?
Let's do it.
Okay. So now we need to add some behavior to our struct. And to do that, we use the special IMPL syntax. I think it's implementation, I think is what it's short for.
Makes sense. Impl.
What else could it be? I don't know.
Yep.
Can't come up with a pun fast enough. Anyway, so any sort of methods go in here, and we can also put some associated functions, which I'm actually going to do. And the difference between the two is a method takes a special self argument in the first position, and that basically gives the method access to the state. So it feels similar to kind of like an object-oriented class instance kind of paradigm, but it's not quite. So, but it feels like it does similar things. So let's create the associated function. So basically we're taking in all the types of our Pokemon struct here, and then we're gonna just return a complete struct. And I know in a previous episode I kind of said I didn't like the automatic return, but for like this feels pretty clean. I like
It
this.
does. Yeah.
And we learned that there's a special feature, which I'm blanking on the name of the feature right now, but basically it's like if we don't have to do like name.
Yeah, it's field shorthand or something like that.
Field shorthand. Yeah, so instead of like that name, we can do health and attack bonus. And as long as the parameter here has the exact same name as the field on the struct, then it all works.
Looks like it's called field init shorthand.
Okay. Well, we are initializing fields. I guess that makes sense. Okay. Yep. So I think that should pretty much work here. And then down here, we would have like a let my Pokemon, and that's equal to Pokemon create and I'm just spitballing some values here.
Okay.
And Pikachu's super powerful.
Here, I'll save and I'll go ahead and run it. Expected struct.
Oh, right.
Found reference.
Yes. So we have like a little associated function inception here.
We do. All right.
So the interesting thing there is it's not immediately apparent to me why this macro doesn't need to do that.
Because we are telling the create function that we're expecting a string, not a reference.
Okay.
I believe so.
Okay, and then we want the ownership to be tied together with all the rest of the state. Okay, now I'm following. Okay.
Cool. I'm going to run this again. Hello world. No errors, just some warnings about unused variables. Yeah.
That's fine.
Cool. Maybe we could print this out.
Yeah. How would we go about doing that, Kate?
So the book talks about using some special built-in things to print out objects, but maybe we could start with just trying to print this out and seeing what happens.
Yeah, go for it.
Okay. Say my Pokemon. Okay, so let's see what happens. That. Okay. Pokemon cannot be formatted with the default formatter. So we have to tell Rust basically how to format this. We can use this thing called an annotation. And I believe if we put it above the struct like this, it will implement this debug trait on our struct and should let us print it. So I still think this won't work though, because we have to kind of change how this interpolation is working. And I believe the syntax is like this. Does that look good?
That looks good to me.
Do you remember what this is called exactly? I forget.
Oh boy. I mean, it looks kind of like some sort of formatting string information.
Yeah. Okay, so that works. We've got this, and then there's an even fancier way to do it. Sean, you're right there. You wanna?
Oh, you want me to do it? Okay.
Go ahead. With the pound sign, and then if we save that, run it again, that'll kind of pretty print it. Oh, sorry, I didn't save. And so we get that nice line breaking and all that.
But you know what's kind of cool there? You notice how when you ran cargo run, when you didn't save, it built a lot quicker?
I did notice that. It's smart.
It's smart. It's like selectively reusing.
Yep. So next step would be to create the two other instance methods that we need, which are attack and is defeated. So I'm going to start
Okay.
with attack here. And I don't think attack would take any parameters except self. And it's going to return an integer.
Mm-hmm.
So we'll use this function to see how much damage to subtract from the other Pokemon. So let's see. We have our attack bonus, but we need our kind of baseline attack. So I think I'm going to create a constant called maybe base attack. We'll also set that to assigned integer. And
Good job with the all caps clean code stuff.
thank you. I don't know. What do you think our base attack should be? I guess we said
I mean, you have 2 written down, but that feels kind of puny to me. Why
it
don't we up
does.
it a little bit?
Maybe 10? That seems reasonable.
Sure.
Okay, so attack is going to return the base attack plus whatever our bonus is. Attack bonus. And return that. So why don't we see if that works? Kind of sanity check that real quick.
Mm-hmm.
We'll say Pokemon attack.
I think you need some curly braces.
Yes. Okay, so I would expect we're passing an attack of 25, so hopefully we'll see 35 if we run this. There we go.
Nice.
Cool.
Cool.
All right, so the next one we need is defeated, which will just return true or false. And I think this will also take self and return a Boolean. Okay, the Pokemon is defeated when their health, when the health is less than or equal to 0. Does that look about right?
Is defeated if health is less than or equal to 0. Yeah, that sounds right.
Cool. So let's print that out again. Okay, and run that. Let's try setting this to -25, see what we come up with. Hopefully that should be true.
Wait, but so that means...
Oh.
Wait, is that negative damage or what does that mean?
Oh, I'm sorry. I did the wrong thing.
That'd be like the hero Pokemon.
Yeah.
Just a buddy.
I like it.
So we are now going to actually simulate the battle. Okay, so we have the ability to create Pokemon. We've got the ability to figure out the amount of damage that they generate from their attack. And we have the ability to see if a Pokemon is defeated. So it feels like we got the pieces we need.
It does.
Okay, so I'm kind of thinking about, we have like a loop, and during a loop, the 2 Pokemon attack each other.
Mm-hmm.
And then if one of the Pokemon has this is defeated thing evaluate to true, then we break out of the loop and it's game over and we know who the winner is.
Sounds reasonable to me.
Okay.
What kind of loop would you start with?
What kind of loop? Let's see. What loops do we know, actually? What have we learned so far?
Well, we have that for loop where we can specify a range. Probably
Right.
that's more for iterating, so probably not appropriate here. Then we have a loop, where we'd have to break out of it. You're not, I believe you're not able to give it any sort of conditions. And
Wait,
then
is that the keyword loop with just
I think so, right?
semicolons?
Yeah. That
I mean, I
seems
feel
like
like
it.
I want something like that
Yeah.
because, or maybe like a while loop with a Boolean flag.
Hmm.
Because it's like with games, you have like an infinite kind of game loop until you have some sort of victory condition,
Yep.
and we don't know exactly how long that's going to take.
Hmm.
Um, let's try this because I'm curious if that's actual syntax.
I'm pretty
So
sure we used that in our first guessing game. Yeah.
okay, I want to do my QBasic thing.
Okay.
This is what all the cool kids did with QBasic. Let's see what that does, and I'll just invoke this here.
Okay.
Yeah. Do you mind running that and having Control C at the ready?
Sure. I don't think that's going to do anything though.
You don't think so?
No. Because
Well,
you're calling it like it's just a normal function, but I don't think it is one.
let's see here. Oh, right, because I have it in the Pokemon thing. So it's an associated
Yeah,
function.
it is.
So it's namespaced. Pokemon. Okay,
Cool.
maybe. What do you think, Navigator?
I think looks promising. I would say that worked.
Yeah. Cool. Okay. So I like that loop. Let's try that.
Sure.
And then I'll just be sure to use the break keyword
Exactly.
to break out of that. But let's make sure break works as we expect.
Yep.
So I'm used to thinking about like you've got break and continue.
Mm-hmm.
So if I do this, I would expect just one string.
All right, let's try it. Cool.
Cool. Okay. Yeah, let's go with that. So if we are battling, I imagine first we're going to need maybe like more than one Pokemon. Otherwise, it's going to be
A
just a
lonely
really
battle.
weird fight.
Yeah, let's get Kirby in there.
Let's get Kirby in there. Okay. That's not a Pokemon, but we'll roll with it. We'll roll with it.
Wait, Kirby's not a Pokemon?
No,
What is
Kirby's
it?
a whole different thing. That's a whole different Nintendo thing.
Oh man. Okay,
Yeah,
well, we need to pick a Pokemon. I was never allowed to watch Pokemon because it was,
because
I
it's
don't
the
know,
devil.
it's something about the devil, violence, yeah, something like that.
It's vaguely
Magic.
reminiscent of dogfighting or something like that. Like that's the part that makes me uncomfortable. Um, but yeah, okay. But no, let's go with Kirby because that's fun. Uh,
Just let my non-Pokemon.
and let's make this personal. So I pick Pikachu and you pick
I feel like I'm
you,
already disqualified before we even start this fight, but okay.
you probably should be. Yeah. Really low attack bonus. Okay, Kate's
My
Pokemon.
only frame of reference for Pokemon is Smash Brothers, so that's
And
why
that's a pretty
why I was
violent game
confused.
too.
It is for sure.
Okay, so health. I feel like Kirby would have a lot of health.
Yeah, let's do 125.
But I feel like a lower attack.
Okay. Yeah, I almost feel like we need maybe eventually to randomize the attack
I don't
so we
know.
can avoid
Are
some
you saying that because you
bias.
think you're gonna lose?
Maybe I'm a little worried. Yeah.
Okay. All right, so we got two Pokemon. Let's go ahead and change this down here to make sure your stuff prints out as we expect.
Yep, that checks out.
That checked out. Cool. Okay, so moving on, we have two different Pokemon. We want them to fight each other, and we have the simulate battle. So I imagine we're probably going to want to pass in like a reference to these two.
Yep, because we would maybe want to use them again at some point, possibly.
Yeah. So in the last chapter, we learned about ownership,
Mm-hmm.
and it seemed like the dominant pattern for passing things into functions would be you pass in a reference, so you don't move the owner.
Mm-hmm.
Because if you move the owner, once it's like, if I did this, then at the end of this loop here, all the data on the heap that's backing this owning variable would be dropped,
Mm-hmm.
basically.
Right, we don't want
So
that.
if we assume that we call like simulate battle, like on this line, and we wanted to access the data below that, we wouldn't be able to because it was dropped.
Yep.
So we will use references. And what am I doing here? One, and that is a reference to a Pokemon. And Pokemon 2, reference to a Pokemon. And down here, we'll pass in my Pokemon
Mm-hmm.
and Kate's fake Pokemon. Okay.
And what are we going to return?
And what are we going to return? So I'm thinking maybe we want to. I'm not sure how this is going to work. Maybe can we do that? Maybe.
Yeah.
So we return a reference to some Pokemon.
Yeah, that makes sense.
And then we do the message processing down here to kind of do the reporting of who won.
Sure.
Okay, so now we have two Pokemon, and we want to return a reference to a Pokemon, maybe a couple of variables, and we'll have kind of like the active and the inactive Pokemon.
Right, because they need to
And
take turns.
they take turns beating on each other.
They're very polite that way.
Okay, something like that.
Yeah.
And yeah, so now we're in the loop.
Uh-huh.
And so, see, the active Pokemon is the one that's doing the damage. The inactive one is getting damaged.
Yeah.
So we need to use these guys.
Yeah, so I would think the active one can call its attack method, and then we'll just subtract that value from the inactive's health.
Okay, so something like that. Wait, hold on. Type I int 8. I8.
Yep.
There we go. That's a type. Okay, and since we are calling a method, we can use this dot syntax. And then call attack. And if I'm remembering right, we don't have to worry about the self stuff here. That's automatically taken care of by the compiler for us, right?
Yeah, and that's I believe it knows to pass self because we're using the dot syntax versus the double colon syntax.
Mm-hmm.
I think that's why it
Okay.
knows.
Yeah, it's self is like a special value, and it knows like myself is whatever's this is.
Right.
Okay. Yeah, that
So,
kind of reminds me of JavaScript and how the this keyword works a little bit.
yeah, for sure. It's
Hmm.
like the difference between calling an instance method and calling a like a static method on a class.
Yeah. Okay.
Similar, similar kind of thing.
Yeah. So okay. So we got our battle damage, and now who's getting battle damaged? Our poor inactive person.
Hmm.
So okay. So inactive. Let's see. Pokemon have health. Okay. So, but if I want to mutate that, I have to
Yep.
do that. Okay. So inactive dot health is equal to something like that.
Yeah, that looks great.
Okay. And so now we've had an attack. The inactive person has been damaged.
Mhm.
I guess we need to check for our end state to see if we need to call break here. Okay, so conditional. So like an if.
Hmm.
And then in our if, we have our
Oh,
inactive and oh, there we go. Okay, so let me just think about that here. So we have like an infinite game loop. We calculate our damage. We deal the damage to the player, and then we check if the person is defeated. But if Pokemon 1 is always active, it's like
it's not really fair.
it's
They're
like a
not taking
bully.
turns. They're not. So they have to switch places somehow.
Wait, hold on. Pokemon 1 is mine. Maybe I'm okay with that though.
You really stacking the game here.
No, I want to play fair. Okay, so I guess we have to swap them. Um,
How do we do that in Rust? I don't know if we've covered swapping really.
so the thing that comes to mind for me would be kind of like the C approach, where we have like a let mute temp.
Hmm.
And then we just have that to basically be able to swap these two, and we use this temp to
Hmm.
hold variables as we move it.
Right.
And then okay.
I wonder if that would work because it's not initialized to anything.
Hmm.
We'll see.
I'm not sure. Yeah, let's see what happens. Okay. So, let's take temp, put active in it.
Hmm.
And then we put active is inactive. And then we put inactive is temp. But I'm thinking, let's see.
Hmm.
Maybe we'll see in a bit. But then I have to return something, and I guess I would do that here. So if we hit the victory condition, we wouldn't swap.
Hmm.
So that would mean inactive loses, which
The
means
active player wins. Yeah.
active. Do you mind running that?
Sure. Lifetime parameter. The book mentioned this, didn't it?
Yeah. It said at one point something to the effect of like, and the real way to fix this would be to use the lifetime parameter,
Right.
which we will conveniently discuss in chapter 10.
Only 5 chapters away.
Something, yeah, something like that. So I guess we don't know that yet. Let's see. I'm trying to think. So did we not use references in the book example, maybe?
Yeah, I'm checking back, and we're using the real values.
Okay. Okay. So in that case, what that would mean is we're moving our two Pokemon into the battle.
Yeah.
Let me think about that here. So we pass in our two Pokemon, which means down here we for reals pass them in.
Yep. So you took off.
And then back in our simulate battle, active. I guess we're moving it there and moving it. And the temp, we'd be moving to that also, I guess.
Seems like a lot of moving around, but I guess we should go with this for now.
Yeah. Okay, let's see here. So we pass in our two Pokemon. We move them. So active and inactive are the owning variables. We enter our loop here. And at the end of each iteration in the loop, we move a bunch. Yeah, that feels inefficient. But let's see.
Yeah, let's see what happens.
See if it runs.
Yep. Okay, it ran.
So it seems good. So then I'm not doing anything with the return value yet. So I could like wrap this in a print line macro call, I guess.
Yeah. Drum roll emoji.
Wait.
There you
go. Cool. Okay. Drum roll, please.
And then maybe we could just return the name. Or we can, could we access the name property here? Right off the call?
Ooh, maybe. See what happens. Dot. It says it's Kate's Pokemon. Ooh.
Maybe. Could work.
That seems like maybe. That seems like a maybe.
All right. Run it.
Yeah.
All right. Wow. That worked pretty well.
Wait, let's make sure that makes sense. Yeah, so Pikachu has a much stronger attack. Mm-hmm. So 35 versus 20. So yeah, that seems right. I think.
Let's switch it up and just make sure that wasn't because yours was first.
Make sure it's not because I'm a cheater.
All right, I'm raising my attack to 100. All right. Nice. Cool. So yeah, we're doing a lot of moving around here with this Pokemon.
Yeah.
I guess it would be an instance of Pokemon. So
I mean, I know like in some higher level languages, you have like the ability to kind of do dynamic swaps through like tuples or arrays where you have like 1,2 is equal to 2,1.
Right. Yep.
That's just kind of like, I feel like that won't work here. So I think in like Python, this kind of thing would work.
Expected identifier. I wonder if we declared line 28 and 29 as a tuple in the first place, if that would actually work better.
Hmm.
But then we would have to use indexes to access active and inactive, which might be a little confusing.
Yeah. I feel like there's probably something better here.
So I'm looking at the Rust documentation, and I'm seeing a standard library. It says swaps the values at two mutable locations without deinitializing the other one. Or, sorry, without deinitializing either one.
I mean, that sounds exactly like what we want.
Yeah.
Okay.
Why don't we try
Do
it
you
out?
want to try to implement that, I guess?
Sure. So I guess I'll need to update our prelude, which there. So we want to use this. I guess, uh, what is the correct term for this? A module. So that's the module. And then I think swap would be the specific package we're looking for. So mem swap. So I'm going to replace this stuff with swap. Nice.
And then for the mem swap, they have mutable for each of the two references they're passing in.
Yes. Great.
Okay, I think. Yeah, now it looks similar. I'm good at copying examples.
Cool. Thank you. That
Wait,
worked.
yeah, that looks good.
Awesome.
Can we take away Kirby's superpowers?
Okay.
Kirby's still gonna win.
All right. Awesome.
Okay, yeah, I'll let Kirby win. That's fine. Pikachu's got some training to do.
Yeah, well, they're not even playing a Pokemon, so it's not really fair to begin with, but
Yeah.
so cool. Cool. Yeah. So next week we have we're going to go over chapter 6, which is enums and pattern matching.
Mm.
Yeah. We don't
I'm
have
really looking forward to getting to like collections and stuff.
Yeah.
I feel like I'm kind of itching for that.
Yeah. You can do a lot more with that. But we don't have enums or pattern matching really in JavaScript, so
Right.
this will be it.
Wait, so
Yeah.
pattern matching is like that. We saw it at the beginning, right? That was like the arms kind of
Right.
thing.
Yeah, that with that match syntax. So
Okay. So we'll dive and understand how that looks or how it works a little bit better.
yeah.
Cool.
All right. Thanks,
Nice.
John.
Thank you, Kate.
Cool. See you next time.
Yep. Later. Bye.